Hi everyone, this is Mrs. GA, and today we're going to talk about the triangle proportionality theorem. So the triangle proportionality theorem states that if a line parallel to the side of a triangle intersects the two other sides, then it divides those sides proportionally. So you can see here that we have a line that is parallel, so EF is parallel to BC, and you can see that it intersects the other two sides of our triangle. So that means that the way EF intersects these side lengths, AB and AC, will be proportional. So we can set up the proportion AE over EB. So you can see I took the two parts from AB, and then it should be proportional with AF over FC. There are other proportions you can set up using the triangle proportionality theorem. For example, of course, we could flip the numerator and denominator both sides, and it would be exactly the same. Okay, so the converse of the triangle proportionality theorem, remember it states the exact opposite, or in the reverse order. If a line divides two sides of a triangle proportionally, so if it's proportional, then it must be parallel to the third side. So if we look at this and we test these proportions, we test that AE over EB is equal to AF over FC, and they are proportional, then that means that EF would be parallel to BC. Okay, so let's look here at example 1. Here we're asked to find the length of segment AC. So to find the length of segment AC, we can see that it would be helpful to first find the length of YC. So we can set up a proportion because we see that these two lines are parallel, and this line intersects the other two sides of a triangle. So we can set up the proportion AX over XB should equal AY over YC. AX is 9, XB is 4, AY is 10, and YC is X. So here we can cross multiply. So we have 9 times X equals 40, so X equals 40 over 9. But remember, we weren't just trying to find this value for X, we actually wanted to find the total length of AC. So we can see that AC is going to be AY plus YC. That's the segment addition postulate. So AC is 10 plus 40 over 9. Let's keep these as improper fractions. So instead of 10 over 1, we can write this as 90 over 9 plus 40 over 9. So this becomes 130 over 9. Okay, so now let's look at this second example. So here they would like us to find the length of segment PN. And again, we have these two parallel lines. So we know that this parallel line is going to divide these sides proportionally. So we can set up the proportion. We can say LP over PN equals MQ over QN. LP is 3, PN is just what we're trying to solve for, MQ is 2, and QN is 5. So again, we can cross multiply here. So we have 2 times segment PM equals 15, so PN is 15 halves. And we can leave it as an improper fraction. Okay, here's our last example. Here we're going to verify that TU and RS are parallel. So remember, we know that these are parallel if these segments are divided proportionally. So I'm going to set up our proportion, and we're going to check to make sure that it's true. So here we can do we can say VT over TR equals VU over US. So 90 over 72 equals 67.5 over 54. So here our goal is just to verify that this is a true statement. So if you do 90 divided by 72, here we get 1.25. And on the right side, if you do 67.5 divided by 54, you also get 1.25. So this is a true statement, which means that the sides were divided proportionally, and therefore using the converse of the triangle proportionality theorem, we can conclude that TU is parallel to RS. And again, it's by the converse of the triangle proportionality theorem. Okay, that is all for today's video. Thank you so much for watching.